Welcome back. This is Friday's lesson, so it should be 5.2b for those of us who have been here every day. Again, this works the best if you have the notes out in front of you and you are following along. This PowerPoint is also on Canvas. At the end, your DOL and homework will come from Canvas. Please make sure that you are pausing the videos and trying them, as I suggest that you pause them and try them. There are some that I will and some that I will not go over, so just be ready for that. Okay, so again, 5.2b. Today we're going to be looking at odd and even functions, and we're going to be able to tell both algebraically and from their graph whether a function is odd or even. So first up, here's your warm-up. Sketch a graph that is symmetric to the x-axis and to the line x equals 0, and then go ahead and check with your partner. So go ahead and pause the video and go ahead and do those three things. Alright, so my example of a graph that is symmetric to the x-axis, well, this one here is the x-axis, so if it's symmetric to that, I guess if we folded that over the x-axis, they would line up with each other. That'll work. Also symmetric to the x-axis would be anything like this. Okay. And then symmetric to the line x equals 0. Well, that line x equals 0 has a special name. It's the y-axis. So an example of that is our good old parabola. You could also do the absolute value function, which is a little v. It's also any line that is a constant, so straight across. Again, if we folded that on the y-axis, they would line up with each other. Okay. If you're not sure about yours, please have someone around you check and see if they agree that the first one is symmetric to the x and the second one is symmetric to the y. Alright, so the next slide, we're going to try to do this as similar as we would in class. So here are 4 graphs. Determine the line of symmetry, if any, and put a star next to the graphs that are not functions. Go ahead and try to work with somebody around you, see if we can find the line of symmetry and whether or not they are functions. On that first graph, the line of symmetry is the y-axis, or what appears to be the y-axis, right there. And this one is, sorry, my dog dropped something. This one is in fact a function. The next line of symmetry for this guy right here is right in the middle of our w. And that one is again a function. Our line of symmetry for this guy, I don't think we have one. If I break it down here, we see that both sides of that are not exactly the same. If we put it here, both sides of that are not the same. Even if I try to go diagonally, we see that there's no line I can draw that, that will cut this exactly in half. This graph does have some sort of symmetry, but it's not line symmetry, okay? This one is still a function. This last one, our line of symmetry is what appears to be the x-axis. And we should put a star next to that one because this one is not a function. It does not pass our vertical line test. Okay. We're going to head back over to your notes for 5.2b. I'm going to do 2a and b with you guys, and then you're responsible for 3a and b. It's pretty much the same thing. Our graph just looks a little bit different. Okay, so 2a says to identify 2 symmetric points. Well, that can be any point over here as long as it also matches with the point over here. The point I'm going to pick, just because, over 2 up 4. I'm going to label that 2, 4. And that's symmetric to, just on the other side of our line of symmetry, negative 2, 4. B says if one point is xy, so this point was our xy, what are the coordinates of the symmetric point? Well, it looks like our two symmetric points had exactly the same xy coordinates, except the x value was negative. So our symmetric point is going to be exactly the same, x comma y, but our x is negative, so I'm going to throw a negative there. Alright, you're going to go ahead and do that same thing for 3, A and B, so go ahead and pause it here. You're identifying two symmetric points on this graph, and then writing if one of those points was xy, what is the coordinate of the other one, okay? When you get done with that, please go ahead and check with somebody around you to make sure that you guys agree. And you can tell from your notes that we've got a bunch of vocab right below there. So we're going to go ahead and get that vocab out of the way. The vocab for today is pretty easy. If a graph is symmetric about a line, the line divides the graph into two equal parts. Special attention is given to when the line of axis, the line of symmetry is the y-axis. That's how we can tell if a function is even. So what that looks like is this first example that we did together. The line of symmetry was the y-axis, so this function is even. We'll talk about even here in a second. We'll get that in our notes, I mean. Okay. Next definition in our notes, a function is symmetric about a point if each point on the graph has a point the same distance from that central point but in the opposite direction. And we pay special attention when the point is the origin, when that's the symmetric point is the origin, because that determines whether or not the function is odd. And then last bit of notes, an even function is a graph that is symmetric about the y-axis. Thus, f of x is the exact same thing we get when we do f of negative x. I'm going to stop us there. We're going to look back at the example that we did together. Notice that f of x, when we plugged in 2, we got 4. We got exactly that same number when we plugged in negative 2. So negative x got us the same thing, got us up to 4, as when we did positive 2. That's what it means to be even. And odd is when we are symmetric about the origin, and f of x is the same thing as negative f of negative x. And then we need to make this note in your notes. This is not the same thing as an even and odd degree function. So this, yes, it is an odd degree, but it is not necessarily an odd function. That does not guarantee that that will happen. I hope because we have seen an example of an even function that you guys will understand what that looks like. Something that is symmetric about the y-axis. I understand that we have not looked at what an odd function looks like, but we will see an example of that, okay? So in your notes, there are, right on the bottom, there are these 3 graphs. And it says, state whether the graph is even, odd, or neither. The way that we can tell if it's even is if it's symmetric about the y-axis. So I'm going to go ahead and I'm going to check all of these for whether or not they're symmetric about the y-axis. We can see from this one Yep, those are the same on both sides of the y-axis, so this one is even. This one here, this is very different over here than it is over here, so it is not even. And this one, these are very similar on both sides of the y-axis, but this one's going up and this one's going down, so it's not even. Okay, so that one's even. For odd, this is our odd function, this last one. And if we look at that, our definition of an odd function is when we have a point the same distance away from the origin, when any point has another point that is the same distance from the origin. So if I pick any point on this odd function, here for example, because it's easy to see, it's this far away from the origin, and just opposite that is this point here. So these points are symmetric about the origin. I can pick any other point that I want. This guy. It's this far from the origin, and if I keep going exactly opposite that, I get another point. Okay, and if I kept doing that, you would see that here connects up here, making this guy odd. Okay, this last one in the middle here is neither. It's not symmetric about the y-axis, which we can see, and then check to see if it's odd. So this point here, it's this far from the origin, and equally distant from that would be here, and that's not on our graph. Okay, so this one is neither. We're going to go off of your guys' notes for a second. So the next few things we do will not be in your notes. It will just be identifying whether which graph is even, odd, or neither. So go ahead and look away from your notes for a second. Again, I want us to be trying these before I give us the answer. So this question is, which graph represents an even function? Go ahead and see if you can find the one that's even. If you are having some trouble, talk to a friend about it, see if they can help explain it to you. Which of these graphs is an even function? And the answer is 4. 4 is the graph that is symmetric about the y-axis. Next question, which of these graphs represents an odd function? Again, go ahead and pause and see if you can answer this one on your own. Which represents an odd function? Odd means it's symmetric about the origin. The only one here that's symmetric about the origin is 3. Alright, we're going to head back into your notes now. We're going to determine algebraically. So now our objective, if you remember, was to do it graphically and algebraically. So graphic, we're done, got that. Algebraically is a little bit more, obviously, algebra intense. So we need to do a little bit more work here. But I broke it up into 2 easy steps. First, we're going to check and see if h of x equals h of negative x. Check and see if those two things are the same. And then from there, we'll see if it's odd by seeing if the answer we got here is the same answer we get when we put a negative in front. Okay, so let's go ahead and do this one out. Again, pause at any time if you need to go back or need to catch up or something like that. So if we want to know if this function, it says f of x, it's the same thing, I just named it differently, is the same as h of negative x, all I'm going to do is put a negative x in for each of these x's up here. From there, I need to simplify, and again, my goal is that if it is even, the answer I get will be this answer here. Okay. The only actual math we need to do is think about what happens when we have a negative to a power. So in this case, it's negative to the 4th power. Well, negative times a negative would be a positive. Times a negative again would get us another negative. Times another negative would get us a positive. So let me do an example of that negative positive stuff, just so you can see that, hopefully clear up some stuff. If we do negative 2 to the 4th power, that's negative 2 times negative 2 times negative 2 times negative 2. These two will be a positive 4. These two would get us another positive 4. So our answer, yeah, it's some number, but the important part is that it's positive. Versus if we did negative 2 to the 3rd power, then it's negative 2 times negative 2 times negative 2. This will get us a positive 4, sorry, negative 2. Then times a negative 2 would get us a negative answer. So anytime we've got a positive or an even exponent, it's going to come out positive. When we've got an odd one, it's going to come out negative. So when we're down here in the problem we're working on, a negative number to an even power is going to be a positive number. So I don't need that negative anymore, because those are always going to be exactly the same thing. Okay, next. This negative x to the 3rd power, what we set up here, if a negative to the third power is going to get us a negative number. So that's going to make this a negative. We got the minus from there. It's going to make us a negative 2x cubed. This is to the 1st power, so nothing's happening there except this will all be negative. And then minus 6. I do have some signs to simplify a little bit. 3x to the 4th, and then I've got minus a negative, which is a positive. I have plus a negative, which is minus, and then minus 6. And the question we're asking when we're saying, is this even? We want to check and see if this is the same as this. Well, it's very similar, but we have a negative 2 here and a positive 2 here, a positive 4 here and a negative 4 here. So these are not the same, so it's not even. It still could be odd, so we are going to check and make sure that it's, or to see whether it's odd or not. It doesn't have to be, it can be neither, that's an option. And the way we check if it's odd is a lot easier. So we're just going to take whatever answer we got here and throw a negative in front. So negative 3x to the 4th plus 2x cubed minus 4x minus 6. Now we have to distribute that negative, but that's really easy. Distribute here, that's negative 3x to the 4th. Distribute negative 2x to the cubed. That was already negative, so it'll become positive. Distribute that negative over here, becomes a positive 6. Is this the same thing we had up here? Nope, so it's not odd. Sorry, I'm realizing I made a huge mistake, not in any of the work, but just in my pointing. We're checking to see if this matches this original, okay? And it doesn't, so it's still not odd. I just pointed wrong. I pointed here and not here. This does not match this, so it's not odd. All right, the next slide in your notes, or in the PowerPoint, is this one about Destiny's work. It's a good one to look over. We're going to skip it for right now, but if you feel like you want to come back and see Destiny, I can certainly point out her mistake. Her mistake was right here. that should not be a negative 3. Negative x to the 4th power will get us a positive number, so this should be a positive 3. Okay? Alright, the next one in your notes is right here. I realize that for some of us this is just going to take some time processing and working through different examples, and probably not until we see one that is even or odd will you understand. I believe this one does come out as one of those things, so let's go ahead and see. Again, step 1, we're just going to check and see if h of x is the same thing as h is negative x, so we're going to plug in a negative for all of those x's. And then we just need to simplify. A negative to an odd power will remain a negative. A negative to an even power will become positive, so there's no sign change here. This is a negative 2 times a negative x, so we're going to get a positive 2x, and then plus 7. And again, we're asking, is this the same as this? It's not. A bunch of our signs are different, so this one is not even. So let's check and see if it's odd. The way that we do that, remember, is that we throw a negative in front of the answer we got here. So negative and we're going to distribute that negative. That will make that a positive. We'll make that one a positive. We'll make that one a negative. And we'll make that one a negative as well. Oh, I lied. I'm sorry. This one did. We're asking, is this the same as this one up here? No, we've got a bunch of sign differences again, so this is not odd. Let's go ahead and see if we can find one that is even or odd. The next thing on the PowerPoint, just so you know, are these questions here. There is no room for them in your notes. They are extra questions if you need them. I will put them at the end of this video, so if you still feel like you need some help, I'll go through these two. Again, I would encourage us to try these on our own before we watch me do them. But let's head back over to your notes. You've got two questions here. Go ahead and take a second to try to do those two, checking to see if they're even, odd, or neither. And then I'll then come back and hit play, and I'll go over those two. Alright, first thing we want to check is it even? This is that first example in the first box in your notes. Is it even? So we're going to put a negative in for all of our x's. Well, in this case we only have one, so it's going to be minus x squared plus 13. A negative to an even power will become positive every single time, so we'll just change our signs there. And we're asking, is this the same as this? Yes, they are exactly the same, so this is even. Fun fact, a function can't be both odd and even, so you're done. You don't need to check if it's odd, but just for giggles, if you wanted to, we'd just put a negative in front of the answer we got there, and make sure you distribute that negative. So it'll be negative 5x squared minus 13, and we're asking, is this the same as our original? It is not, so it's not odd. Again, you didn't have to do that because if something is even, it's never odd. Okay, move over to the second one. So the second problem in the box in your notes, doing that same thing, putting a negative in for the x. Again, there's only one x here. A negative to a odd power will change our sign, so it's going to be negative 4. x to the third minus 6. If it's even, this will match this. It does not. Those 4's are different signs, so this is not even. And to check if it's odd, we're going to throw a negative in front of this whole thing. And make sure we distribute that. So it'll be a positive 4x cubed. And then change our signs here. So it'll be a positive 6. And we're asking, is this the same as this? It's not, because those 6 are different signs. So this is also not odd. If you are struggling or you are not sure what it would look like if it was odd, because we haven't seen an example of that yet, you can go ahead and watch the next problem that I do. If you feel like you're doing all right and you think you can do the DOL, you can go ahead and do that. It's here. You talk through that really fast. Determine whether the function is even, odd, or neither, and explain your reasoning. Again, this is on Canvas. And then determine algebraically whether each function is even, odd, or neither. You will do that algebraically, okay, like we've been doing. If you feel like you need help, just hang out in the video for a second. I'll do 2 more questions with you, and then you'll come back to this DOL. Alright, as promised, here are those 2 extra questions. I would, again, try these on your own first, and then watch me go through it, pick up any mistakes that you made along the way. For f of x, starting with the first one, first thing we're going to do is see if it's even. The way we do that is by putting negatives in for both of our x's and seeing if they're the same. So I'm going to do 2 negative x to the third minus 3 negative x. Now a negative to an odd power is going to make it negative, so we're going to change our sign. Now we have negative 3 times negative x, so that's a positive 3x. And we're asking, is this the same as our original? No, it is not. So this is not even. We still have to check and see if it's odd. The way we do that is just by putting a negative in front of the answer we got there. Make sure that you distribute, oh sorry, that's a plus. Make sure that you distribute to each of them. So a negative times a negative, we'll get that as a positive 2. A negative times a positive will get us a negative 3x. And we're asking, is this the same as our original? Yes, it is. So this is odd. Because this matched our original, this is odd. Okay, that was the first example that we saw of a function that was odd. And the next problem, again, pause it to try it on your own first. You're checking to make sure we did it correctly. First thing we're doing is seeing if it's even. So we're going to take negative x to put in for the x's. A negative times a negative will give us a positive, so we're not changing our sign here. We're asking, is this the same as our original? Yes, it is. So this is even. And then because it's even, we know it's not odd, but just so you're practicing to check if it's odd, we throw a negative in front of the whole thing and make sure we distribute. So it'll be negative 6x squared, negative 10, and we're asking, is this the same as our original? No, it is not, so it's not odd. Alright, please go ahead and try your 5.2b DOL and then work on any homework that we have. Please make sure that since I've been gone, you should have done 5.1, 5.2a, and 5.2b. I will be checking all 3 homeworks on Monday. Hope you guys have a good weekend. Bye.